system has a on and off switch here and a 13.8 volt 10 amp maximum cigarette lighter socket. It's got a 300 watt AC Pure Sine Wave Inverter, and it has two Type A USB ports that are 2.4 amps each. Hi, this is Chris, and I may be going a little COVID crazy, but I'm going to show you how to hack this Ryobi Supercharger that holds 6 batteries and have it turn it into a regulated 13.8 volt supply with a 300 watt Pure Sine Wave Inverter. So a lot of the viewers sent me messages saying they really liked my battery systems for the Ryobi batteries, the Powerstations, ones with different inverters and regulators and things like that, but they said they just didn't have access to a 3D printer like I do. So this project's going to try to use off-the-shelf components so that someone without a printer can build one of these systems. So I already had one of these Ryobi 6 battery superchargers. It charges one battery at a time and cycles through them. But then I needed 2 new batteries for my Ryobi lawnmower, and they had the sale where with 2 4 amp hour batteries you could get a free tool. In this case I picked another one of these superchargers, which I'm going to disassemble. So it has T20 security screws, and if you take them out at the bottom you can see there's quite a bit of stuff in here. So now there's Phillips head screws that you have to take out. So after taking the Phillips head screws out, this piece comes out, and I still have to remove the temperature sensor wires, and you can see the PCB board has the 3 contacts on it. So now we're left with the piece that has the lock-ins for the batteries, and you'll have 2 of these. And on the PCB board that has the 3 contacts, 2 wires, there's a power wire and there's a ribbon cable that have to get disconnected. So now you have the circuit board disconnected. You can see for each outlet you have a battery plus, a T1, battery minus, and a T2. So now we're taking the master board out. So the 2 halves come apart. You have to take the label off the handle, and it looks like you have to undo these 2 screws. So it looks like there's 2 T9s that have to come out that on the cord clamp. So the guts are all removed, and now we can use the case. We're going to use the Best Tech 300 watt Pure Sine Wave Inverter for our project. There are 4 rubber feet on the bottom of it, and you can just pull them out with a long nose plier. Once you take the plugs out, you can remove the small Phillips head screws. Then the cover pops off. We're going to drill 2 holes in this so we can mount it to the back of the charger here, and then we'll put the plate back on. The holes are drilled and the plate seems to fit on there. Now we'll take it off and put the cover back on the inverter. We're going to be using this DC to DC converter. It takes 8 to 36 volt input and outputs 13.8 volts up to 25 amps. And we're going to place it inside the top of the 6 charger. So I've marked and drilled 4 holes, and we'll put bolts on and bolt it in. The buck converter is now installed. Next I drilled a 1-inch hole where the USB port used to be, and I'm putting this 12 volt cigarette lighter socket there. Here the cigarette lighter is installed. You can see the terminals on the inside here. Next I drilled a 1/2 inch hole for this on-off switch. cut off the cigarette lighter socket that went to the inverter so I can wire it in to the output of the buck converter along with the socket cigarette lighter here. Made up 2 short wires that are going to go to the cigarette lighter socket. So I have the output ground from the buck converter connected to the ground of the cigarette lighter and the ground of the inverter, and then I connected it to the ground of the switch, and the plus from the output of the buck converter connected to the cigarette lighter and to the inverter. It turns out that the traces on the PCB board are enough for charging at 2 amps, but it's not enough if we're going to draw 10 amps out of the batteries. So I'm going to run a extra set of 10 gauge wire between all the terminals, and I'm going to clip these temperature connectors because they're kind of in the way. Well, it's not pretty, but I soldered wires onto each of the terminal connectors, and then I put some liquid tape on them just to make sure that I don't short them by accident. Got the other side soldered, and I'm just going to put some liquid tape on these contacts too. Okay, I think I have everything hooked up now. So each of these boards has a plus and minus wire. I've got the pluses tied together and they go to the switch, and the minuses are connected together. One of them goes down to the DC to DC inverter. So before I button everything up, I'm going to put the battery in each one of the slots, just a single battery, and make sure that it lights up my I'm getting 13.7 volts and the light switch is on. So I'm going to repeat that for each one of the sockets to make sure everything's connected correctly. I have everything screwed back together, and I've tested it with one battery. So I have the 12 volt socket, and I have just a little converter here that tells you the voltage. So if I turn on the system, it says we have 13.7 volts. Right now I'm just using one battery. I can turn on the inverter. The light goes on. Since we're using the 6 batteries in parallel, it's extremely important that they all be the same size and all have the same charge level. So I suggest only putting fully charged batteries into it. So in my case here, I have 6 4 amp hour batteries that are fully charged. You can see by the green lights on the supercharger here. I'm currently using 6 4 amp hour batteries, so that gives you over 400 watt hours of power. With the 6 4 amp hour batteries, the package weighs about 16 pounds. For a test, I've got 2 100 watt light bulbs and a 75 watt light bulb, and I'm plugged into my inverter. You can see the inverter's driving the bulbs. It says it's 110 volts it's getting, and it's doing 247 watts. To test the cigarette lighter output, I've got my battery tester, and I've got it set to almost 10 amps. There you go. And the voltage just dropped down to 13.2 under load. And I'm actually powering the tester off the inverter. As you can see, I've been a real busy bee. I hope you found this project useful. If you did, please hit like and subscribe. Have a great day.